So if we look at the factoring tree, and we've gone over the previous lesson, where the first thing I do, no matter how many terms, is common factor first. And then we said if there's two terms, is it a difference of squares? Yes. Then here's the formula for changing it from standard form to factored form. And if it's not a difference of squares, is it a difference or sum of cubes? Yes. Then here's your outline here of what to do if it's a difference of cubes or a sum of cubes. And if it's not, then try factor theorem. If we have three terms, is it simple or complex trinomial? And if it is, I use the sum and product method. And if it's not, try factor theorem. Then we just went over the video of four terms, 2 by 2, 3 by 1, or 1 by 3 factoring. And if group factoring doesn't work, again, everything's leading to, if everything else doesn't work, try factor theorem. So that is what we're looking at today, is factoring review part 2, which is the integral zero theorem, factor theorem, and there's two different theorems. So we'll do them in two separate videos. So let's say I had an example like this. X cubed minus 4x squared minus 11x plus 30, right? So it's not a binomial, it's not a trinomial, and let's say factor by grouping. We just tried 3 different ways of factoring by grouping, right? Where you have to have a trinomial here, and let's say it doesn't work. So if x minus b is a factor of this polynomial with a leading coefficient of 1, there's a 1 in front here, and the remaining coefficients are integers, meaning not decimals or rational numbers, not fractions, then these two things hold true. The factor that I get, b, is a factor of the constant term of p of x. We're just going to call this expression p of x, and b is a 0 of p of x to be a factor. So I'm going to move this up and show you what I mean, so I have more room to write the answer. So this here is a cubic polynomial. So what I want to do if I'm using factor theorem is look at the constant at the end, the positive 30, and I want to list all the factors I have of 30. List the factors of 30. So for example, I have positive 1 and negative 1, right, are factors of 30. Positive and negative 2, positive and negative 3, 4, positive and negative 5, positive and negative 6, right, because 4 doesn't work. Anything bigger than 6. Does 7 work? Does 8 work? 8, 16, 24, 32, right? 9, 18, 27. 10 would work, so positive and negative 10. Positive and negative 15. And positive and negative 30. So we have, for each number, it's 2, because you have the positive and the negative. So we have 2, 4, 6, 8, 10, 12, 14, 16 possible answers here that I can use to help me factor this question. So what I want to do first is we keep talking about p of x. So let's let p of x be equal to this expression. X cubed minus 4x squared minus 11x plus 30. And make sure I have my signs right. What we want to do is, instead of p of x, these are my factors, my possible x values. Basically, there's no real easy way to go about this. Let's just start with the first factor, and what we're trying to do is plug it in and see if we get 0 as an answer. And if we don't get 0 as an answer, then it's not a factor, then that's not helping us to factor the question. So for example, if we start at p of 1, I'm going to have 1 cubed minus 4 times 1 squared minus 11 times 1. You're just plus 30, you're just subbing in 1 for x. So that would be 1 minus 1 squared is 1 times negative 4 minus 4 minus 11 plus 30. You could start here with 1 and then take away 4 and get -3, then take away 11 and then add 30. Or you could take your positive numbers together, 1 and 30, let's say, and get 31, and then minus 15, -4, subtract 11. Either way you do it, you should end up with an answer of 16, which is not 0, right? So that means that x minus 1, because remember up here, let me just move back up here for a second. It says x minus b is a factor. So whatever b is, it's x minus b. So we just put in 1 as our value of b. So x minus b, so x minus 1 will not be a factor. So x minus 1 is not a factor of that expression. So next is the negative part, the negative one. So let's try p at -1. So I would have -1 in brackets cubed minus 4 times, whenever you're subbing in for x, put it in brackets, especially if it's negative, minus 11 times -1 plus 30. So here I would have -1 cubed would be -1. -1 squared is +1, so multiplied by -4, I'm still getting -4 like before. But now I have a negative and negative, so now I have +11 plus 30. So again, you can add that different ways. I can add the negatives together. -1 subtract 4 is -5, and 11 plus 30 would be 41. So then altogether I get an answer of +36. Excuse me. So either way, 36 is not 0. We're looking to get 0. So my b value is -1, right? So x minus -1 would end up being x plus 1 is not a factor. So let's go down the row here and try p at 2. So always go back up to the original. And if you want to, you could highlight it, making sure you're going back to the original. So I have 2 cubed minus 4 times 2 squared minus 11 times 2 plus 30. So 2 times 2 is 4 times 2 is 8. 2 squared is 4. -4 times 4 would be -16. -22 plus 30. Is this looking promising? Do I look like I have an even amount on the negative side and positive side here? If I were to take my, let's say, negatives, -16 minus 22, I would get -38, and 8 plus 30, +38, and we get 0. Yay! We don't have to do any more work at this point. So that means that b was 2, right? So it's x minus b, so x minus 2 is a factor of p of x. So that's giving me part of my answer. I know that part of my answer is x minus 2. That's the binomial part of my factored answer. Now I need to figure out what the trinomial part of the factor would be. And in order to do that, we have to do long division or synthetic division. So for this example, I'll show both. You can pick which way you like the best and do it that way if you'd like from then on. So if I'm doing it the long division way, I take my factored answer that I just received, which was x minus 2, and I divide by my original, right up here, x cubed minus 4x squared minus 11x plus 30. So when I'm doing long division, I'm only looking at 2 terms at a time. So here I would start by saying x multiplied by what will get me to x cubed. So x multiplied by x squared will give me x cubed as an answer. And then I multiply only the 2 terms. So I have x multiplied by x squared gives me my x cubed. And then I have the negative 2 multiplied by x squared is giving me negative 2 x squared. And for long division, I'm always subtracting out here, just the 2 terms. So my x cubes will cancel out, and I have negative 4 like terms, right? Negative 4 plus 2 would give me negative 2 x squared. And then I bring down my 11x, negative 11x. So then I look once again, x multiplied by what will get me to negative 2x squared? Or negative 2x squared divided by 1x would be negative 2x, correct? So then negative 2x goes on top of my long division sign. So x multiplied by negative 2x gives me the negative 2x squared. And then the negative 2 multiplied by negative 2x, negative and negative, give me positive 4x. And again, all the way along, I'm subtracting. So negative 2x squared plus 2x squared gives me the cancel out, and negative 11 minus positive 4, negative 11 minus 4 gives me negative 15x. And I bring down my 30, positive 30. And I start again. X multiplied by what will give me negative 15x, or negative 15x divided by x would give me negative 15. So x multiplied by negative 15 is my negative 15x. And negative 2 multiplied by negative 15 gives me positive 30. And again, I'm subtracting. So that ends up being negative 15x plus 15x. And 30 minus 30 gives me my 0 remainder that I want. So then my answer would be here. And we can go one step further, but I'll do that with synthetic division. X minus 2, for example. And then the answer here on top of my long division sign. So x squared minus 2x minus 15. That's a simple trinomial. We can go one step farther. We're not done, but I'll show that, like I said, in the synthetic division. I think I can fit it side by side here just to show both ways. Or synthetic division. You're only using the numbers and not the variables. So I take my factor, which was a 2, and I put it out in front. And I take just the numbers as part of this expression. Kind of an upside down dividing line. So the 1 in front here, put spaces beside it, then negative 4, have a space, then have a space, negative 11, and then have a space for 30. And what you do is you bring the number 1 down, and when you cross over this line, you multiply by your outside factor. So as soon as I cross over this line here, it means I'm taking 1 and multiplying it by 2, which is 2. And for synthetic, though, it's opposite. you are adding. Instead of subtracting here, you are adding every time. So -4 plus 2 is -2. So now I have -2 underneath the line. When that -2 comes over the line and crosses, I multiply by the factor out in front, 2. So I get -4. And again, just a reminder, I'm adding those numbers. So -11 plus -4 would give me -15. So then that -15 crosses the line and gets multiplied by the factor out in front. So I have -30. And then when I add 30 plus -30, I get my 0 remainder. So how do I turn that into an answer? So again, I have my 2, which is a factor. And remember from above, it's always x minus b. So x minus whatever my factor number is. And then these answers here are in order from left to right, part of the answers to my question. So this would be the constant, this would be the x, this would be the x squared. So I have a single x squared minus 2x minus 15. And then again, always double check if you can factor further, right? This is a simple trinomial. So I need to use the product sum method now, right? A is 1, it's a simple trinomial. And look for two numbers that multiply to -15 and add to -2. So again here, what multiplies to 15? 1 times 15, 2 times anything, 3 times 5, 4, and then again, when I have 5 times 3 and go backwards, these are the only. So what has a difference of 2 there? The 5 and the 3, right? Then it's just a matter of my signs. If I'm multiplying to a negative and I want to add to a negative, I want the bigger number to be negative and the smaller number to be positive. So then my final answer would be x minus 2. Break this down into a product of binomials as well. X plus 3 and x minus 5. And after all that work, that is the factored form of the expression x cubed minus 4x squared minus 11x plus 30. And again, it doesn't matter what order these are in. It can have the x plus 3 first, it could have the x minus 5 first, that doesn't matter, right?